Okay, so we have similar truss problem again. There is a pin at point C and there is a rocker at point A. So rocker will have a normal reaction force and pin will have the support reactions in X and Y directions. And then the question says that, again, what is the members, each of them are in tension or compression. We have additional force of 600 newtons this way at point B, D, and then we have 400 newtons load at point B. The length of D to C is 4 meters, and the length from A to B is 3 meters, again 3 meters from B to D. So step 1, as always, will be the global equation. So we'll write the equilibrium equations for whole setup. And then we will write the equilibrium equations for each of the joints. Okay, so let's do that. So first, the x direction forces. We have x direction force as Cx, which is negative. I will take this direction as positive. And then we have 600. Okay, so from here it follows that Cx is 600 newtons. And then we have the y direction forces, which is Cy. Sorry, this should be up. As positive, so we have the Cy, we have the Ay, and we have this 400. Okay, and you can see that we have two unknowns but one equation. So we need one more equation to find these unknowns. So that final equation will come from the equilibrium of rotation. So we will say that the moment about any point is 0. So I will choose the point A, but you can choose any point. Even you can choose a point outside this truss. So I will say that the moment about A is 0. So it means that this 400 times 3, it creates a clockwise moment this way and negative. This Cx creates a moment this way, which is a counterclockwise moment, times the arm of it is 4 meters. Okay, and I know that Cx is 600. And then Cy creates a moment about the A, again in counterclockwise sense, with an arm of 6. This one is counterclockwise. Cy times 6, again counterclockwise. And then the 600 creates a, so this one passes through the point A and it doesn't create any moment. So that will be equal to 0. Okay. So if we solve it, we will see that Cy is equal to, so we have 2400s here, 1200s here, so it will be negative 1200s, and so negative 200. That's for Cy. Okay, so we have the value for Cy, which is negative 200 newtons. Then we can go back and then find the value for Ay. From here it follows that Ay is negative 200, negative 400, and 600 newtons. Okay. So the result says that direction for Cx is correct, 600, which balances this force. The direction for Cy is, that should be the opposite, this way. So this balances the moment by 400, and then the direction by the Ay is positive, which is up. Again, this balances this 400 and then this Cy force. Okay, so with this in mind, we finished step 1, and then the time is to move to step 2, which is to write the equilibrium equations for each of these joints. Okay, so let me write what we have found. We said that this Cx is 600 newtons, Cy is negative 200 newtons, and Ay is 600 newtons. Okay, so now I will start from joint A, and then B, and then C, and then D. So let's firstly go with the joint A. There is a reaction force of 600 newtons. There is a force, again I will assume it is tensile force by FAD. And there is a force, again I will assume a tensile force by FAB. Okay. And this FAB has an angle here. This one is theta angle, and I know that this theta angle can be found by 3 meters. This one is 4, and this will be 5. 3, 4, 5 triangle. Okay, so I can easily find it, and this theta, it will be just 3, 4, and 5, and then this will be the theta. Okay, so we have two unknowns. Essentially we have two equations, so we can find the unknown ones. So I will say this one is for joint A, so this will be 0. We have the force of FAD, which is positive, and the cosine component of FAB, which is again positive. The cosine is 3 by 5, and that will be equal to 0. Similarly, the y will be equal to 0, 600. Again, this one is positive, but the sine component now comes, so we'll have the FAB. Sine of theta is 4 by 5. That will be 0. Okay, and then if you solve it, we will have that FAB is negative 600 times 5 by 4. That will be negative 750 newtons. Okay, that is FAB. And then we will have FAD. So this one, 3 by 5, that will be our FAD value. So this one divided by 5 makes 150, times 3 is 450. So it becomes that FAD is 450 newtons. Okay. So result says that the direction for FAD is correct, this way, 450, but direction for FAB is negative, so it should be that way. It is, in other words, a compressive force acting on joint A. That force, so it will be that FAB is negative 750 newtons and FAD is 450 newtons. Okay. Now I will move on to joint B. For joint B, we have a force BC, we have a force BD, and we have a force AB. And for AB, we have found that the force is not this way, but the force is that way. Okay, so since it is negative, I will put it here as compression, positive tensile. Okay, and since this one compresses the A, equal and opposite one should compress the B. So I will just call this one as FAB. Okay, again Newton's third law. For B to D, we have again 3, 4, and then 5. So this is B to D, so we will have this part is 4, this part is 3, that part is 5, and that is the angle theta, and the same angle theta here. Okay, so let's write the forces. So first we will have the x components will be 0. Okay, the angle for FAB, it was theta here, so let's just call it as a different angle. It's alpha here. So for FAB, so it was, so we had this one as 3, this one as 4, and this one as alpha. Okay, this one is for AB, and this one is for BD. Okay. X component of FAB is positive, okay. So that will be, FAB is 750, and its x component will be cosine of the angle, which is 3 by 5, plus FBC, okay, and then plus FBD as a cosine component, which is positive again, so it will be FBD. Cosine of this theta is 3 by 5 again. Okay. Now comes the y component. So we have two unknowns. Okay. For a y component, so we have FBD and FAB only. For the y component forces, we will have FAB y component, so which means that 750 times the sine of the angle, which is 4 by 5, and then FBD y component, which is negative, again the sine of it, which is 4 by 5, and then we have negative 400 is equal to 0. Okay. So we have 750 by 5, 150, times 4, 600, minus 400, 200, times 5,000 by 4, 250. So from here, FBD is 250 newtons. Okay, and this one is 250. If I replace back here, 250 by 5, 50, 150. So we have 150 times 3, 450, and then we have 600. So FBC will be negative 600. Okay. So if I add it here, so FBD will be 250 newtons, FBC will be negative 600 newtons. Okay. Again, this one is a tensile member, the force. This one is a compressive force because the direction is negative. So FBC, so we assume it that way, so it comes out to be this way. So we have A, B, and then times to find C, and then D. Okay, so time comes for the joint C. The C will have a CY, which is negative 200. I will just put this one as this way. CX, which is positive. And then there is BC, which is negative, so it means that this one is BC, which is 600. Okay, and there is CD. Okay, so 600, 600, this one is in equilibrium, and this one CD, and then this part by the f of y is equal to 0, it follows that FCD is negative 200 newtons. Okay, so again, this one is a compressive force. Okay, so if I come back to point D, for D I know BD from this part, I know CD that I just found, and I know AD I know from here. You can write D and check if it is true or not, but I will not do for our case. Okay, so you can do the same case for joint D, but I will not do, and then you can just write D to check if it is true or not. But for our case, I will finish the problem and determine if the members are in tension or equilibrium, tension or compression. Okay, so let's find if the members are in tension or compression. So first, AB, so we have found that this one is negative 750, so this will be 750. And A to D was positive, so this one is 450. And then B to A, it will be the opposite by Newton's third law. And then BC was negative, so again this will be 600. And then this one will be again by Newton's third law, equal and opposite. And then CD, which was negative, again 200 and 200, 450, 450. So we will have equal but the opposite forces. You can check equal and opposite, equal and opposite, equal and opposite, equal and opposite. Okay, but these are for joints. So we have to write the forces for the members. We have to find the members are in equilibrium or not. To find it, this one is 750, so you will have equal and opposite, equal and opposite. So this means that AB is in compression. 450, equal and opposite, equal and opposite. So AD is tensile. Here, equal and opposite, equal and opposite. CD is compressive. Here, equal and opposite, equal and opposite. BC is compressive. Okay. So we have compressive, 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 and tensile member. So this finishes the problem. So if I summarize the steps, first, we do the global equilibrium equations for the whole truss, and then we write the equilibrium equations for each of them, and then we have found the forces for joint A, joint B, joint C, and joint D. And then by Newton's third law, this will have an opposite force at each point, so we will have AD is in tension